So this lesson starts the next chapter of Algebra 2, and what we're going to be learning in this chapter, to start with, it's going to be some review that you learned in Algebra 1, and then we'll get into some newer stuff. That's kind of how, most chapters that we've done this year have gone. So this chapter is about solving systems of equations, and we're also going to get into systems of inequalities, and I don't know if you remember, but that's when you do like the shading and stuff like that. We get into that stuff. There are three methods of solving systems of equations that you learned back in Algebra 1. You learned how to solve a system by graphing, which is how we're going to start. You learned how to solve a system by substitution, which we're also going to do in this lesson. And then you learned how to solve a system by elimination, which we'll do next time, okay? So to remind you what we're trying to accomplish when we solve a system in general, we're trying to find the point that makes both equations true at the same time, the ordered pair that will satisfy both equations. And when we graph, we're really just graphing both lines and looking at where they cross, if you'll remember. So I'm going to graph this first line at y-intercept at -10. The slope is +2, so I go up 2 over 1. Now here's the deal. When we first graphed lines, I said plot 2 points, draw your line, and be done with it. But now the accuracy of our lines matter because we're trying to figure out where they cross. So I'm going to actually keep plotting points. I'm going to keep going up 2 over 1, and that's going to let us get a pretty accurate answer in the end. So I'm going to keep plotting points. And then I'm going to use a ruler, and I'm going to draw my line. Now, let me explain what this line is and what it represents. Every point on this line, if I would pick any point on this line and plug it in for x and y in this top equation, it will make the top equation true. It'll satisfy the top equation. But I don't care about the points that satisfy the top equation. I'm after the point that satisfies both at the same time, and that's why we have to graph the second line. So I'm going to put my y-intercept at 5. My slope is -3, so down 3, right 1. Down 3, right 1. Down 3, right 1. Now here's the deal. As soon as I figure out one point is going to be matching on top of the other, I could stop there. I don't need to keep plotting points. There's no point for that because we're just after where these two things cross. And I notice that they cross right here at the ordered pair 3, -4, and that would be my answer. I would write 3, -4 as an ordered pair. And I could check it. If some of you love to check your answers. If I plug 3 in for x, I should get -4 for y, and it should happen for both equations. You double check both, and it does work. On B, well, you notice on B, we just have to get y by itself to start with. Hopefully we're pretty good at that. So the top equation, I'm going to subtract 2x over. And then the second one, I'm going to subtract x. And then divide everything by -4. So y equals, well, this becomes +1/4 x. Doesn't become 4x. That's probably the biggest mistake students make. They'll say this is 4x, but it's 1/4 x, and then -2. And then I'm not going to keep going, but you would just graph both these lines and see where they cross. I just wanted to remind you guys how to get y by itself. I am going to do the next two because they are interesting. This one, to me, once I graph these, the same exact thing happens as example 1. So I'm not going to waste your time there. So C, okay. So C, I need to get y by itself first. So I'm going to subtract 3x. And then on the bottom one, I'm going to subtract 6x. And divide by 2. Now you'll notice something here, you actually end up with the same exact line. Like if I plot this top line and the y-intercept is 5 and the slope is -3, well, if I plot that line here and then I plot the second line, I'm going to get the same exact line. You get the same exact thing on top of itself. And I want you to think back. You did this back in Algebra 1, but a lot of people forget with this answer. A lot of people would say all real numbers. That's actually not the answer. The answer to this is infinitely many solutions. Infinitely many solutions. And I'm okay if you abbreviate that with IMS for infinitely many solutions, right there. The difference between infinitely many solutions and all real numbers, there is a difference between those answers, and all real numbers is wrong. If you say all real numbers, then you are basically saying no matter what ordered pair you pick anywhere in the coordinate plane, it's going to work. It's going to satisfy the system. If you say all real numbers, you're saying this point right here, for example, is a solution. You're saying every single number is a solution. And that's not true. The only solutions are the ones along the line right here. Those are the ones. There's infinitely many of them because that line goes on forever, but we can't say all real numbers because not every number actually works. The only other special case that could happen is if you run into two parallel lines. You know, if you go and graph your two lines and, for instance, they're parallel to each other, meaning they'll never intersect, then we would say no solution. Or after where they cross, if they don't cross, then there's no solution. All right, then the very last one. I'm going to go ahead and do this one. You'll see why. So I plot the y-intercept at -5. My slope is 3, so up 3 over 1. Up 3 over 1, up 3 over 1. I'm going to keep going. And I'm going to graph that line. Hello, line. Okay. And then I'm going to graph the second one. So the y-intercept is 4. The slope is -2, so down 2, right 1. Down 2, right 1. Down 2, So you notice something interesting happens on this. You know, going back to the very first example, we had a dot on each line like match up right on top, and they crossed at like what I like to call crosshairs, like whole numbers. Well, on this one, we don't have a dot match up. And there's a reason why I'm doing this. So now we have to pick an answer. I've had students in the past say, well, there is no answer. Well, there is an answer. The answer is where these cross. The problem is, it's not crossing at whole numbers, and we have to kind of estimate. I might say the answer to this, and I don't know the exact answer, but I might say the answer to this is like 1.9, comma 0.5, or something like that. So I'm just going to say 1.9, comma 0.5. I'm just guessing. I'm approximating. My reason for doing this one is to explain that, yes, graphing is a method to solve systems, but it is not a good method to solve systems. It is not a good one at all because sometimes this happens and then you have to guess and you don't know what the answer is exactly. Oftentimes we'll be dealing with like word problems where the numbers are in thousands and thousands of dollars and we don't want to graph on coordinate planes that are in the thousands. It's just not fun to work with. So enter the other method. Well, there's going to be two, but enter the next method we're going to talk about. Is substitution. So when you guys learned this in Algebra 1, you probably learned how to solve by graphing. That's my hope, because that's what solving a system is. But it's not a very good method, and that's why you learn two algebraic methods. So the rest of the notes are, okay, how else can we solve systems? Well, we can solve by substitution. Now I'm going to kind of show you the process for solving by substitution. If I look at this very first one, now those of you that remember systems quite a bit, in all honesty, this first system is set up for elimination very quickly. Because if I just add these equations together, the y is going to go away. And as this chapter progresses, you guys are going to get choice in how you want to solve your systems. You know, if we take a quiz, I might have one problem where it says solve this one by substitution. And then I might have another where it says solve by elimination, just to see that you know how to do each one. But I will never, ever give you a system that's set up for elimination and make you solve by substitution. I think that would be silly. But I am going to remind you guys of this process. So when we're doing substitution, here's our goal. We need to pick one of these four letters and get it by itself. We need to isolate one of these four letters. You guys have choice. Now, I would choose a letter, if I can, where there's just a positive 1 in front of it. Like the second y right here, I can very easily get this y by itself by just subtracting 6x over to the other side, and then I've accomplished, the first part of the goal. But let's say you're like, well, I'm just going to get this top x by itself. Well, then you have to add y, and then divide everything by 4, and then you're going to have some messy fractions to deal with throughout the rest of the problem. It's not wrong, but you want to make your life as easy as possible. So I'm going to get y on bottom by itself. So y equals negative 6x minus 6. I just took 6x and subtracted it over. Now enter the substitution part. Now that we know what y equals, like y equals this right here, we can take this and plug it or substitute it in for y in the other equation. Our whole goal, we're trying to get to one equation that has just x's in it, or in general, one equation that has just one letter in it. So I'm going to replace the top y with what y equals. So it would be 4x minus, and then here's the important part. Anytime you substitute, you have to use parentheses. Anytime you plug something in for something else, you have to use parentheses. And the reason is because that minus sign right here is going to distribute inside those parentheses. But notice I have an equation now with just x's in it. I'm going to solve it. So 4x, distribute the negative, so plus 6x, plus 6. Combine like terms, so 10x is negative 5, subtract the 6. Divide by 10. Your brain is going to want to say negative 2, but remember, when you divide by 10, x is negative 1/2. All right. Now, I still have to find the y value. I get to plug negative 1/2 into any of these equations up here that we started with, or even this very bottom one right here. So I could plug negative 1/2 in for x in any of these equations. The easiest one is the one that we got y by itself. So I'm going to plug negative 1/2 in for x right here. And so that's going to be positive 3 minus 6, so negative 3. And then I'm going to write my final answer as an ordered pair. And these are checkable. I could plug those in for x and y and figure out the answer there. That is substitution. Okay, example 2. So we have a word problem here, and we actually solved these word problems last semester. Some of you solved these with systems of equations, and I mentioned at the time that, systems probably is the way to go, but I didn't really get into it at the time. But some of you chose to use systems of equations. It says $12,000 is invested into two different accounts. One gives 5% interest, the other gives 3% interest. The yearly interest gained is $500. How much is invested at each rate? Okay, so last semester we had X be one of the two accounts. Well, now that we're doing systems and we're trying to find two different things, like how much went into 5% and how much went into 3%, we can actually use two different variables. So I'm going to have X be the amount of $12,000 that goes into 5%. So the amount invested at 5%. Then Y is going to be the amount of 12,000. So the rest, it's going to be the rest of 12,000 that goes in at 3%. So the amount at 3%. And our goal, we're trying to find X and Y. So I need two different equations from this word problem to set up with X and Y. Well, the very first one is this. I know X is a portion of $12,000. And I know Y is the rest of that $12,000. Meaning, if I add X and Y together, I sure as heck better end up with $12,000. So I add my two variables, it's 12,000. Then we have the interest equation. I get 5% from whatever X is, and I get 3% from whatever Y is. That's how much interest I get from each account, and it tells me I get $500 in interest. So the way I do this equation it'd be 0.05x, because that's 5% of x, plus 0.03y. So this is how much interest I get from the 5% account. This is how much interest I get from the 3% account. And altogether, we get $500 in interest. And there's my system. When we do systems, especially with word problems, we'll do a bunch more next class, you get to choose how you want to solve them. Because this is the substitution lesson, I'm going to use substitution. Now, me personally, and this is me, I don't like working with these decimals, like 0.05 and 0.03. So what I like to do, and you do not have to do this, I like to take everything in this equation and multiply it by 100. And that's going to get rid of my decimals. Basically, I'm moving all the decimals to the right 2 places. So I'm going to make this be 5x, 3y, and then 50,000. I'm just multiplying everything by 100. And then I just lightly cross out that middle one. I'm done with that equation. Here's my system right here. And now I'm going to solve it just like we did back in example 1. So I need to get one of these 4 letters by itself. It really doesn't matter, but I would choose one of the top 2 because there's a positive 1 in front of each. You're not going to have fractions to worry about. So maybe I'll get this y by itself. So y equals 12,000 minus x. I'm just subtracting x over to the other side. Now I take what y is and substitute it in for y in the other equation. You have to make sure you plug it into the other equation, because if you plug it into the one you just solved for, everything is just going to cancel out. You're not going to get anywhere. You have to use the other equation. So I have 5x plus 3 times 12,000 minus x equals 50,000. Notice I put it in parentheses, and also notice I have a new equation with just x's in it that I'm going to solve for. So distribute the 3. Notice I get negative 3x there. I'm going to combine the x's and subtract 36,000 over. So 2x is 14,000. Which means x is 7,000. Now, with word problems, I'm not going to put my answer as an ordered pair. I actually want to write a brief little statement that answers the questions. And this is why we define the variables at the very beginning. This means $7,000 went into that account that gave 5% interest. You had 12,000 total, and 7,000 of it you're putting into that 5% account. Well, that means 5,000, the rest, goes into the 3% account. So to write that final answer, I would say $7,000 at 5%. I don't need to write like a full sentence. And then $5,000 at 3%. And you could check these too. You could check word problems. If you add 7,000 and 5,000, you should get 12,000. And then also, if you take 5% of 7,000 and 3% of 5,000, you should end up with 500 total. Just multiply that by 0.05 and multiply that by 0.03 and add them. You should get 500. So you can check. All right, the last one. Kind of a newer one. We're still using substitution, but we have quadratics involved right here. So get excited. Okay, so for me, I like to pick a letter to get by itself where there's a positive 1, preferably. But these both have negatives, so that's fine. Here's a little trick that I like to do. Instead of like subtracting 2x and then dividing everything by negative 1, I just like to add y to the other side. So that'll make it positive y. And then just add 1 over to the left. So instead of, again, subtracting 2x and dividing, I just add the y over, and now it's positive, but I have to add the 1 to the left. So 2x plus 1 equals y. Just a little tip. Now I'm going to take what y equals and plug it in for y in the top equation. So x squared plus 4x minus, and then I have to put 2x plus 1 in parentheses, equals 7. All I did was replace y with what y equals. And now I have a quadratic to solve, and hopefully it's ingrained in you guys. When you have a quadratic, move everything to one side. Set it equal to 0. So I'm going to do some If I distribute the negative, that would be minus 2x minus 1. So let's see, 2x minus 1. Subtract 7. And now we can use quadratic formula, or we can factor. I'm going to factor this. And so x is negative 4, and x is 2. Well, what this means is that we actually have two different answers. And I want to kind of explain why. But think about graphing. If I graphed this top equation, we would actually get a parabola. Because it's a y equals x squared graph, we'd get a parabola. So that top graph is a parabola. And then the second one is a linear equation. So think about what could happen if you graph a line and a parabola. We actually end up with two different intersection points. And that's what's happening here. We're figuring out these graphs intersect when x is negative 4 and when x is 2. But we have to find the corresponding y values for each of these. So I'm going to plug negative 4 in for x right here. And when I do that, I don't need to show this, but when I plug negative 4 in, I get negative 7. So one answer is negative 4, negative 7. And then plug 2 in, and you get 5. So the other answer is 2, 5. So there are actually two answers to that system there. All right. Try the homework. Let me know if you have any questions.